Hey, welcome to the last instalment on the quadratic function, and we're going to go backwards and forwards here in between having a formula and drawing the graph and coming back to the formula. So let's have a look. If you had the formula here and you had x take alpha, x take beta, I guess finding where it cuts the x-axis would be pretty easy. You could put one factor equal to naught or the other, and you would have the values alpha and beta. Don't forget, they could all be different steepnesses. I could draw one in here which is steeper, or it could have a negative a in front. Don't forget negative a's. So what we're going to do is see how good you are in going backwards and forwards. And there isn't any actually new concept here. It's just pulling together some of the things that go right back to year 10. What about this one over here? If you have a touching point, that's a repeated zero, isn't it? X take alpha by x take alpha. And don't forget the a, because they could have different steepnesses, or it could even be negative ones coming in and touching there. Keep that in mind. What about down the bottom over here, where we're not given the axes intercepts, instead we're given the vertex? Hey, do you remember? X take h squared plus k, completion of the square. Can you take either form, either the graph and go back up here, or not the graph, hang on, graph and go down there, or the formula and go back up there? Don't forget, different steepnesses in there. Okay, and if it's negative, it's going to be like that for that a value. Are you getting the hang of this? It's quite good to be able to do it both ways, backwards and forwards. And what about over here, where we've got x-intercepts that aren't perfectly whole numbers perhaps? We're going to use the formula for the roots of a quadratic. Okay, this thing here, and the discriminant has got the symbol delta, b squared take 4ac over 2a, to get those intercepts. And just remembering, halfway between is the axis of symmetry, or the x value of the vertex, which is x is neg b over 2a. So you can do it all with formulas as well. So a formula approach over here, going backwards and forwards from the graph to the formula. Okay. If we come back up here, I forgot to say something about this one up here. Just remembering here that the axis of symmetry is always halfway between the x-intercepts, isn't it? Okay, because there's symmetry in a parabola, and the line of symmetry is halfway between the x value, so it's the mean of the x-intercepts there. Okay, we've done that before, but it's just a bit of a review now. Okay, let's go and do some stuff with this. See how good you are. Can you remember all of this? So here we're first of all going to take a formula and sketch the graph. So the ones we're going to take are in the factored form. So it should be easy to work out the x-intercepts. Let's do it. So the x-intercepts is occur when the function is 0. So you put this equal to naught and get the opposite sign, neg 3. Put this equal to naught and get 1. Then you could try to find the y-intercept, couldn't you, by sticking x is naught in each of these places. And you'd have 2 by 3 by neg 1 would be neg 6. So we can get a good picture here. It goes through at neg 6, neg 3 and 1. All old stuff actually. Let's do one from over here in part B. Put this equal to naught or this equal to naught to make the function 0, or to cut the x-axis. So it's got x-intercepts of 1 and 2. And when you put x as naught in here, you'll get neg 2 by neg 1. Put x as naught in here, neg 2. Because where it cuts the y-axis is when x is naught. So this comes to neg 4. The y-intercept is neg 4. So we're down here. X-intercepts at 1 and 2, and do you see there? Neg 2 means it's concave, or concave down if you like. Okay, what's that negative out the front? Alright, what about the last one? It's a repeated factor, x plus 2 squared, or x plus 2 by x plus 2. And where's it cut the x-axis? When the function is 0. So it just touches at neg 2, because there's a repeated one. Okay. And so, also in this one, putting x is equal to 0 to find where it cuts the y-axis, it would be a half of 2 squared, which would be 2. So we can get that point, a touching point, and it's a positive in front for the half, and so away we go and draw it. Just trying to get symmetry there. If you draw that in, you can get a good point over here, symmetry from that point to get the fatness of the curve right there when you haven't got two x-intercepts. All right, are you ready to have a go? Let's have a go at 1k1. Okay, and doing it exactly the same way. Maybe I'll just take this up here a little too so you can see the steps. Okay. All right. Pause the presentation. I think you should quickly graph all of those, and then let's look at the answers. Okay, so down here some graphs for you. These are the graphs you should have gotten, and here are the axes of symmetry here, halfway between the intercepts, all right, or neg b over 2a, if you want to use a formula approach. Okay, let's move on. Let's see if we can do some more connection of formulas to graphs. And why does that work? Here's a perfect square type. Can you work with that? Okay, we're going to do the vertex, axis of symmetry, and a y-intercept again. The vertex can be read straight off though. X take h squared plus k. X take h squared plus k always gives you a vertex of hk. That's a perfect square stuff that we did a fair while ago now. So, it's neg h. So if it's plus 1, it's over here neg 1. It's the same sign, however, as the y value down the end. And the axis of symmetry is always x equals the x value of the vertex. The y-intercept is when x is 0, stick it in here, 0, so it's neg 2 by 1 squared plus 4. So that's positive 2. And then we notice, look at this, neg 2. A is negative, so it's concave, or concave downwards, you might want to say. Okay, let's try and draw it. Neg 1, 4 plots there. 2 is the y-intercept, and draw the axis of symmetry through. So then you might take a point, same distance the other side. I call that a freebie. You don't have to actually calculate anything. A freebie point, just to get a bit of fatness there, or symmetry, across that axis of symmetry. All right, so this one involves going from the vertex form back to a graph. Okay, let's have a look. Pause the presentation. You need to do all of these in this particular case. Now let's have a look at the solutions to those. And here's our graphs, half a dozen graphs there. All right, check it all out. Should draw in the axis of symmetry and label it. All right. Let's move on. Keep going backwards and forwards between the formula and the graph. Okay, so let's have a look here for this one now. This is not factored. It's not in that form. And it's also not in this form. Okay, they are good forms because you can get the axes intercepts. The x-intercepts can be read off quite easily from here, and from this form, just remembering what we've just done, you can read off the vertex. So what do you do with this? Well, this is one where you might use the formula. Okay, so let's have a look. Let's find the axis of symmetry. Axis of symmetry is x equals neg b over 2a. List them down. A is 2, b is 6, c is neg 3. Now, how do you find the coordinates of the vertex? Well, if the axis of symmetry is x is neg 3 over 2, that is the x value of the vertex. So you take that x value and you stick it back in place of x in the formula to get the y value. Okay, there it is in place of x in the formula, which is neg 7.5. So the vertex is the point neg 3 over 2, neg 7.5. Down there, draw in the axis of symmetry. Now find the y-intercept. Put x as 0 back in the formula. So it's 2 times 0 squared plus 6 times 0. It's always the number down the end, isn't it, in this form. So the y-intercept is -3, there it is. Now this does not factorise, so we have to use the formula for the roots of a quadratic. Do you remember? Neg b plus or minus square root b squared take 4ac over 2a. When you do that, we get these approximate decimals. Okay. So there we have it. A lot more work in this one when it's in what's called the general form. Okay, let's have a look at some for you to do. Half a dozen there. Hang on, I'll just push this up here because we don't want to show you the answers. Okay, think you need to do those 6. We're still going forwards, aren't we? From the formula to the graph. And shortly we want to go backwards from the graph back to the formula. See how good you are. Okay, let's have a look at the answers now. Okay, so here they are. Most of them, it's A, B, C, D, E. I think there's F coming up. Okay, have a look. Check that you have got all the features correctly and mark them on the diagram. And then there's E and F. All right. Are you feeling powerful? It looks like you know the quadratic pretty well by now. Okay, let's go on and have a look. And here's a revision of the discriminant. Okay, b squared take 4ac, the part that comes under the root sign in the formula. Neg b plus or minus square root b squared take 4ac over 2a. Here it is. It discriminates between not cutting the x-axis when you can't find the square root of a negative, touching the x-axis when the two roots are the same, because b squared take 4ac would be 0, and plus or minus the root of 0 is the same, or the discriminant positive, there'll be 2 different values. Okay, let's have a look. We've done all this before. Let's have a look at this example. Thank you to Hayes and Harris for screen clippings here. Have a look at their textbook. So in this one, you're just going to use the discriminant, not going to do the whole graph. Just take a peek at it. So you write down the number in front of x squared, a is 1. Number in front of x, b is 3. Constant down the end is 4. Work out b squared take 4ac, 9 take 16, neg 7, it's less than 0. Therefore it doesn't cut the x-axis. What would it look like? Well, a is 1, so it's going to be greater than 0, therefore opens upwards, but it doesn't get to the x-axis. Okay? It's usually called positive definite, but it doesn't matter here about that in this particular course. Let's do the other one. A is neg 2, write it down over here. B is 5, write it down. C is 1, write it down. Calculate b squared take 4ac, 5 squared take 4 by a, use a bracket, what's the negatives? Negative times the negatives are positive, 33, that's greater than 0, cuts the axis twice. Hang on, but a up here, neg 2. So a is less than 0, so it goes through here at 2 places, and we haven't done the whole formula, so we don't know what they are, but we know it opens downwards, so it looks something like that. We're taking a peek at the graph here using the discriminant. We've done this before. Okay, we'll study that. I want you to have a go at some down here. Here we are. I'll hide those answers again there. Use the discriminant to determine the relationship between the graph and the x-axis. So just pop in there and work out your a equals, b equals, c equals, put it all together in b squared take 4ac, and just take a peek at what it's doing with the x-axis. All right, let's go down. You need to do all of these, and then we'll have a look at the answers. So pause it, have a go. Here are some answers here for you. Did you get them right? Okay, half a dozen of them. Okay, check it. You could use technology to check it, actually. All right, let's go backwards. Determining the quadratic formula from the graph. How good are you? Can you go backwards? Okay. Find the equation of the quadratic with a graph like this. Wow, what would you do? Axes, intercepts to the rescue. So neg 1 and 3, therefore I'll go to this form. Don't forget the a. There could be different steepnesses. We don't know how steep this one is yet. X take the x value, x plus 1, x take 3. Remember, this is because of the null factor law. when you put this equal to naught, you'll have x plus 1 equals naught. It'll give you the opposite sign, won't it? Just remember where it comes from. You always should specify that a is not equal to naught, because if a is naught, you don't have anything over there. Naught times anything is just nothing. Now, how are we going to find this a? Well, look up here. When x is naught, y is 3. So let's stick it there. Y is 3, x is naught, that will come to 1, x is naught, that'll come to neg 3. We're substituting in. So then the next step would be 3 equals neg 3a, divide both sides by neg 3, a would be neg 1. So we can actually find that value there. Okay, let's do another one. This one's touching. So we know the factored form is a, not sure of its steepness yet, but x take 2 squared, because it touches, and a is not equal to naught. Find a point. There's a nice easy point. X is naught, y is 8. Stick it in place there. Y is 8. A is still there. X is naught, so it becomes neg 2 squared. So a is 2. So the formula is 2 outside of 2x take 2 squared. All right, let's do some of that factored type. So you're going to use this approach. What is the approach? Remember, x take alpha by x take beta. We're going to go backwards to that if we know the x-intercepts. So if we know alpha and beta, that's the form we will use to hunt down the actual formula for the graph. Going backwards now. Okay, let's have a look at these down here. Okay, I'll just come up here to find the equation of the quadratic with those graphs. So do all 6 of those, and I'll show you the solutions after we look at this question too. Okay, so this is making up your complete formula yourself from the factored form. So we would start with this, just like you've seen there before, and use the factored form where you've got the intercepts known here, alpha and beta. Okay, let's do question 2. Question 2 is a fun question because it gives you some formulas and you've got to match them with the graph. Okay, so is A? I don't think so. Okay, so you've got to match this one, find its x-intercepts, have a look at its steepness, is it concave up or concave down, and then go and find which graph matches A, and go through each of them. Be careful here, this sign in front would mean concave down. So I would suggest a strategy of look at the x-intercepts in this factored form, and look at A, and see whether you're looking for concave up or concave down. Okay, because there might be some tricky do's in here, that they might have the same intercepts but be going oppositely, concave up or concave down instead. Okay, pause it, have a match up there. I'll show you the answers to those 2 questions now. Okay, let's come down. There are our matchups. Okay, so there's question 1, the formulas you had to construct, and here are our matchups between the graphs and the potential formulas. Quite a fun activity, that one. Okay, not much to go now, so hang on in there and let's get those skills going. So you might have guessed what we're going to do here. We're going to start with a graph here that's got something to do with the vertex. So here it is, axis of symmetry, x is 1. So we know this has got x is 1 there. And the other x-intercept here, and we've got one x-intercept, is neg 2. So what would this be? Has to be the same distance the other side. So that's 3. This has to be 3. So the other x-intercept is 4. So we can go back using the axis of symmetry and get both of the x-intercepts by symmetry here. Just remembering, the x-intercepts are the same distance each side of that axis. Rather an interesting one. Don't forget the A. Now we look for a point. Oh yeah, x is 0, y is 16, same as before. 16 equals a, put x is 0 in here, times 2 by neg 4. So a would be neg 2, and the quadratic would be this one. All right, have a go using that approach now. Down here, find the quadratic with this graph. Okay, question 3. Okay, don't forget the a, and you need to substitute in a point to just check the steepness of it. All right, let's have a look at the answers. All right, a few little answers there for question 3 in the factored form. We're going to go on and look more at using a vertex approach on the graph. Okay. Now let's have a look now in the form, general form now. And it goes through the x-axis at 4 and neg 3 and passes through that point. So not a graph so much, information from the graph. So since we've got the x-intercepts, we'll do this form. X take 4 and x take neg 3. Then we can say, well, we've got to find a. But we're given the point x is 2 and y is neg 20. So putting y as neg 20 here, you get neg 20 equals a by 2 take 4. Instead of 0 in here, we have to use the x value of the point we're given on the curve. And then 2 plus 3. So we get a is 2. And therefore we've got that form. Because they want it in the general form, we have to expand it using FOIL. First outers, inners, last. Okay, only slight difference there. So I want you to try and use that procedure on these. Okay, they're all ones where the x-intercepts are given. Okay, pause it, have a go, and let's have a look at the answers now. Okay, so there are all the formulas for you. All right, just a little bit further and you'll be fully qualified in quadratic functions. Okay, here's the one I was promising you. I'll just bring this up here. Here we're given the vertex of the graph in both cases. So you're going to say, I know the vertex formula is this. Various steepnesses, but it's going to have a vertex of hk. Okay, so 3 neg 2 is our vertex, so it's a, various steepnesses, x take 3 squared, take 2. Remember, it's the opposite of that, x take h, x take 3. Now we need to use this point to get a, x is 0, y is 16. So let's put y as 16, and we're trying to find a, x is 0, that'll disappear, neg 3 squared, take 2. So it's 9a take 2, and if we rearrange that, add 2 to both sides, 9a equals 18. No need to switch that, you can work this way, nothing wrong with that. Okay, can do that. So a is 2, so putting it all back together again, we've got that perfect squared form. Vertex neg 4 2, same thing. It's going to be various steepnesses. X take, the x value of the vertex, that'll be x take neg 4 is x plus 4 squared, plus 2. Okay. And now we've got here, we've got a value there when x is neg 2, y is 0. Can you see, to evaluate this a, we only need any point. It doesn't have to be the y-intercept, could be the x-intercept or some other point. So we're going to substitute in this point. When x is neg 2, y is 0. So instead of y, we put 0 equals a, put in neg 2 here, neg 2 plus 4 is plus 2 squared, plus 2. So here we have 4a equals neg 2, putting that on the other side, and a is neg a half. So it's neg a half, x plus 4 squared plus 2. And that explains why it's concave down. Notice in our sketching, we're not really worried about accurately portraying the steepness there. But we are interested in whether it's positive or negative, because that makes a bigger difference. Big difference. Negative like that, and the positive value of a gives you a graph like that. So we're interested in that, but we're not trying to actually draw accurately the steepnesses. Okay, let's have a look at some for you now and see what you think. question 5. So remember, you have to use the vertex, and you will need one other point to evaluate A. Just let's reiterate that. We know the general form is this, and we can go and get these from the vertex, but we'll need to substitute in a point to evaluate the A value, the steepness there. Okay. Have a go, and I'll show you the answers down below now. Okay, so that's question 5, and that's it. You are now officially fully qualified in working with algebra and the quadratic function. Congratulations. We'll catch you in a future presentation. Cheers for now.